Welcome to the Building Massive IoT series episode 2. My name is Alper Yegin. I'm the CTO of Actility, Vice Chair of the Board, and Chair of the Technical Committee in the LoRa Alliance. Like we did in episode 1, here we continue to bring more insights to you about the LoRaWAN technology and LPWAN in general. In this episode, our very first topic is the recently published LoRaWAN standard evolution that was published by the LoRa Alliance. I'd like to go over the details of the evolutionary roadmap and tell you about the ongoing work in the LoRa Alliance. So let's look at the evolution of the LoRaWAN diagram together. This whole thing started back in 2015 when LoRa Alliance has published the very first specification that described the so-called LoRaWAN, which now we call the LoRaWAN link layer specification. It's a single protocol that runs between the end device and the network to provide framing and connection manager. And this is one work stream which has started back in 2015, and we kept evolving that through new versions of the LoRaWAN link layers, starting with 1.0, 101, 102, and all the way to 1.1. And a little later, we realized the need to separate the regional parameters document from the link layer spec so we could keep adding new regions, new channel plans without having to impact the link layer spec. And also soon after the very first link layer spec, we started certification. This is the certification for the end device, which primarily focused on the link layer spec and later added other specifications as well, such as SHIC compression and firmware update over the air. The third work stream started when we wanted to decompose the network. Instead of treating network as a monolithic entity, we realized the need to split it into the so-called network server, join server, and the application server, and start defining the interoperable APIs among them in order to enable features like roaming and also activation. And that gave birth to the so-called backend specifications. And the roaming eventually evolved to even support roaming hub, and we keep pushing forward on that work stream as well. And the fourth work stream has been a number of specs to facilitate device onboarding and device management, such as QR-based device identification and the firmware update over the air for managing a fleet of devices and updating their software and firmware, and also the new work items coming, which I'll talk a little later. And the fifth work stream is about supporting the application domain. And here we've looked at the existing legacy application domains to see how we can easily adapt LoRaWAN to support these domains. For example, IPv6 over LoRaWAN falls into this category, as there are numerous IP-based applications. And in order to run IP over LoRaWAN, we had to do significant compression on the IP headers and the other higher layer headers. And that's where we have collaborated with the IETF through LPWAN working group to build the SHIC feature. And that basically opened up supporting practically any IP-based service over LoRaWAN. And another good example is the use of support of DLMS, also through this IPv6 adoption. And we have got into building a standard for normalizing the so-called application codecs. These are pieces of code, mostly JavaScript code, that translates between binary encoded payload and the JSON. And through the standardization of the API, now we can enable a device or an application codec built once to be run on any stance-compliant application server platform. So these are all the different work streams that we have now, starting from a single over-the-air protocol to a full end-to-end architecture. And we have numerous other work items that are ongoing to keep evolving this architecture, such as satellite connectivity enhancements. Today, there are already multiple satellite service providers providing connectivity through LEO and GEO satellites. Now, in this new work item, we're looking at further optimizations and also increasing the interoperability space, so these services can work with commercially off-the-shelf products and devices. Drive-by, walk-by reading, or also known as mobile gateway, is another work stream we have started to provide coverage in the most remote areas where building a fixed network is not cost-effective. Instead, a mobile gateway is used for mostly reading water and gas meters, and it also has applicability beyond that. On the backend side, standardizing the interface between the application server and the network servers, and also between the gateways, LoRaWAN gateways and network servers, are two other ongoing work to evolve the core network APIs. And finally, on the link layer spec, we are bringing in crypto agility in order to support ever-evolving set of crypto suites. So right now we support only AES 128, but moving forward, we'll be able to support AES 256 and any other crypto suite that comes afterwards. As you see, over time, we have expanded our architecture in multiple dimensions, and we keep evolving. So if you'd like to be part of this evolution, not only as an adapter of the technology, but also as a contributor, you're more than welcome to come and join us in the LoRa Alliance Technical Committee. Next, my guest is this time the other co-inventor of the LoRa technology, Olivier Seller. Olivier is one of the co-inventors of the LoRa modulation technology. He is the technical fellow at Semtech. And more importantly, he's my colleague from LoRa Alliance. We've been co-chairing the technical committee in the LoRa Alliance together. Welcome, Olivier. Great to see you.
Yeah, thank you, Alper. And indeed, it's been a pleasure to work with you in the TC for so many years now and so many years to come. And congratulations for your re-election at the TC chair.
Thank you. Another 2 years together. So, okay, like I did in my previous interview, the one with Nicolas Sonin, what I'd like to start with is going back to the days when you guys were building the LoRa technology. I and the viewers are wondering, what were you thinking? What was your vision this technology would be, or what problem it would be solving? And then just to talk about looking at where it is right now, what is the delta and what does it tell us?
Yeah, okay, sure. So I think, at least from my side, there was no plan, no real vision. It was really a technical challenge, and also maybe a rebel thing. Everybody was looking at 4G, 5G, higher data rate Wi-Fi. So everyone was into higher data rate, therefore shorter range and higher power. And with Nicolas, we set the challenge to ourselves to go the other way. Mm-hmm. So longer range, lower power, and of course lower data rate. So we worked and we decided to use chirps because it's a convenient way to do low data rate and low power at the same time. But I think we didn't have really a vision. It was really a technical challenge. When we discovered that we had succeeded in some way, that we had this wow effect, showing the demonstration, well, we were lucky, I think, to meet the IoT market. Maybe you know that quote from Seneca, the ancient Greek, that luck is what happens when preparation meets opportunity. So for us, the preparation was a technical challenge, and the opportunity was this IoT market, which was really one big surprise. Not that the fact that the market exists, but how the market is organized. The fact that we need to be organized as an ecosystem, as an innovation ecosystem, where many, many different players collaborate, including competitors, collaborate to provide the final value proposition. And even the end user of the technology, of the LoRaWAN technology, need to innovate. they don't only need to learn how to use, they also need to change the way they work, possibly change business model, create new business models before this value proposition comes to reality. So it's really a chain of actors, a complete innovation ecosystem, which is required to provide the IoT innovation. So that's really that's indeed the biggest surprise, how we are organized now, in the LoRa Alliance ecosystem.
Yeah, definitely. I mean, it's a great combination of great engineering, technology, and an ecosystem, the two becoming, and then providing this very explosive end result. And regarding, what you were saying, people were working on 4G and 5G. I was with Samsung Electronics back then, and the team I was in, we were working on 5G. And when we looked at the requirement set, none of them had anything to do with IoT. None of them resembled anything like what we are solving today. It was all about increasing the network capacity, the data rate, and everything in the total opposite direction, which clearly gave another technology to us, which is very power hungry and short range. Obviously, it does solve a problem on its own, but then it left a huge gap behind, right? And this is exactly what we've been filling. And starting with the journey you guys have started back then, and yeah, it's been pretty exciting. So, and then starting from where we are right now, looking at what is ahead of us in terms of the evolution of the LoRa modulation and its brothers and sisters you guys have been bringing to the market. So what is the latest already out there, and what we can expect to see down the pipeline?
So you will see on the physical layer, on LoRa itself, you will see gradual improvements, nothing revolutionary, but typically better radio performances, so better sensitivity, somehow better resistance to interference, better power consumption, also sharper, so nicer transmit spectrum to fit better in the spectrum we have, and also and last, better resistance to Doppler. Mm-hmm. So that's overall better radio performances. We're also going to stack more features and also optimize for the new features that we've been defining in the LoRa Alliance. For instance, the features which are really close to the physical layer are the relay and CSMA, carrier sense multiple access. So in both cases, this relies on channel activity detection, so the capability to detect quickly and efficiently the presence of some signal, of some LoRa signal. So we are going to improve in the next chip generations. We're going to improve this channel activity detector phase to make it better selective, better sensitive, and also lower power. And overall, the trend we're talking about chips is more integration, more features on systems, also power management. But I mean, for that, I cannot disclose. You please stay tuned for our next chip announcements. That's not going to be announced before the chip is there.
Sure, we will definitely stay tuned. And going back to the Doppler effect you mentioned, assuming it's not for bullet trains or people driving super crazy on highways, it must be for something that's moving fast, even faster. So we're talking about satellites here, right? So what can you tell us on that front? So I mean, LoRaWAN is now also being used in space with base stations flying above. And what's the what is new on that front? What is next for us? What should we expect to see with the LoRaWAN coming from the blue sky?
So for the satellite communication, specifically the uplink, I think in the satellite language this is called the return link, from the ground to the satellite. So we use. LoRaWAN uses LRF-HSS, which stands for Long Range Frequency Opening Spectrum. Difficult to say. I trained for that. And we have Semtech has worked with partners to improve the LRF-HSS receivers, which are in the satellite, to improve the resistance to interference, to improve the capacity, the demodulation capacity of such receiver, and also to improve the performance versus Doppler rate. And since we need to use LoRa on the downlink because it's much easier to receive, we have also worked on improving the Doppler, as I mentioned earlier, and you're right, that's for satellite. So there are multiple satellite operators, partners that use the technology. The first one were Lacuna. We also have EchoStar with a commercial service, and Eutelsat and Planes, who have commercial plans, not announced yet, but they're not just working for the beauty of science. This goes to either low Earth orbit LEO or geostationary satellites, and really it's that this modulation, which is specific for satellite, for the case where few gateways serve many end devices which are hard to reach. And of course, the extreme case of that is satellites, because there's one gateway with many end devices which are difficult to reach because they are far away. There might be terrestrial applications to LRFHSS. Again, if there are few gateways trying to receive many end devices which are hard to reach, but the focus, honestly, is on satellites.
So the radio technology is evolving to support different deployment types, right? From ground, we're going to the space, and then we all recognize that no single wireless communication technology can solve all sorts of use cases because of the limitations of the physics. So it's not surprising that there are multiple radio technologies in the market, and Semtech has recently acquired Sierra Wireless. Now you guys not only have LoRaWAN, but also cellular IoT. So what is your view on the relationship between LoRaWAN on one side and the cellular IoT on the other side, and how do they relate to each other, and how would they address the market?
So first, I would like to start answering that the IoT market is becoming more mature, if not mature, becoming mature for real. And with maturity comes the recognition or the fact that we understand that no technology can solve it all. Therefore, convergence is required again to provide the value to the end user, and convergence and combination of technologies. So that's a necessity, and that's also a good thing because it makes the capabilities broader. With LoRaWAN, we have a long history of collaboration with cellular IoT because, well, with cellular at least, because most gateways have a cellular backhaul. So it's really, in that case, LoRaWAN is used to distribute some connectivity which comes from cellular. We are expanding that in the LoRa Alliance with activity, by the way, but in the project to have battery operated relays which are backhauled with a cellular connection. So it's really a way to have a battery operated gateway again. So it's based on the relay, because that's really the purpose of the relay, battery operated gateway, easy to deploy, easy to manage, with a cellular backhaul. So not to have the burden of having a LoRaWAN backhaul, which is the normal backhaul of a relay. So we see that we're going to use the cellular technologies to scale the LoRaWAN networks. And cellular IoT on is also very good on its own, because wherever there is coverage, it's almost unbeatable, I would say, when it comes to price. Even power consumption, I mean, is okay, higher than LoRaWAN, but probably good enough for many use cases. But really, coverage is the thing. There is a huge cellular IoT coverage, which comes from 4G and 5G coverage. Even without coverage, you have private LTE, 4G, or this that can be deployed if you can offer the price and maybe also the power consumption. So there is a long history back in the past and a bright future of convergence between technologies, with the sweet spot being, in my opinion, LoRaWAN to distribute cellular connectivity.
Yeah, definitely. I mean, for where we stand or where I stand as well, they're very complementary. So it's not like LTE and WiMAX, which had a head-on collision, whereas these technologies are very complementary, much like 3G and Wi-Fi, when there was such a discussion back in the early 2000s. And clearly the market has already sorted this out. There are many operators that deploy both Narrowband IoT, LTE-M, and LoRaWAN side by side. And there are many combinations, like you were saying. Sometimes cellular is the backhaul, sometimes LoRaWAN is the backhaul, or to control the cellular infrastructure. And there's many ways these two technology families get mixed and complement each other. So, and on our side as well, in Actility, the ThinkPark, we support both LoRaWAN radio networks and also cellular IoT radio networks under a single platform. So that's definitely a very good direction. That's, I think, by now pretty well understood by majority of the market, but still there are some camps thinking one has to win, one has to lose, but that's definitely not the case. But then there are also other wireless communication technologies. So we're not alone. It's not just a two-horse race. There are other technologies coming in, going out. So depending on the year we are in, we can talk about, like, if you go back, it could be Wi-SUN, it could be Sigfox, and so which other wireless technology is taking your attention, and what's your view on those technologies?
So LoRaWAN, we are one of the leading technologies for IoT, and considering the ecosystem, I think we are certainly the leading ecosystem with an open technology, an open platform, and an open ecosystem, an open alliance. So on the ecosystem front, we are certainly leading. Sigfox is one important competitor. Sigfox has joined the LoRa Alliance recently, which is a proof that they also have recognized the need for convergence, and that's what they are doing now. They are providing Sigfox and LoRaWAN operation depending on countries, depending on cases, depending on use cases, and depending on the coverage they already have. So convergence is there with Sigfox. There's another technology which is really in its infancy. It's MyOT. They are really starting, and you can see that from their marketing, which really makes me think to the good old times of the IoT hype. And MyOT technology-wise is a little bit like Sigfox, I would say. It's mostly uplink. It's really designed for many uplinks to one gateway. Slightly shorter range, but in some of the ways it's better. But it's a little bit like Sigfox in my opinion. But there will be more. What we need to do is to keep on innovating, keep on adding features at every layer in the protocol, in the physical layer, in the services, to keep this competitive advantage that we have with the ecosystem.
Right. Yeah. Like you said, we keep marching forward. Among all these technologies, if any one of those does find a place for themselves, we're welcome. We welcome them to coexist. Integrate, converge, like with the cellular IoT, and it's a big space. But obviously, there needs to be a clear value proposition from those other technologies. And the technical advancements we have, and the large ecosystem, which is a key differentiator. These are what's setting us apart. So we'll see where they land eventually. And Olivier, my last question is about the future. Now we talked about the past, today, the current, and what's the future. what is your view on what would be the future of LoRaWAN looking at the next 10 years and beyond? What are we gonna have our what are we gonna see in our retirement? What are our kids gonna see and the grandchildren will be seeing with the LoRaWAN technology?
Okay, so that's a more difficult question, especially since I'm not a man of vision, as I said in the beginning. But to answer quickly, I think when we retire, we wouldn't have seen the end of it. The IoT has now passed the hype curve. We are now on the plateau of productivity, according to what Gartner consultants think, meaning that we are now in a steady growth phase, and we're going to see long-term adoption of IoT. It's going to take some time. Therefore, we will see it will not be over by when we retire. Even 30 years is not going to be over. However, it's going to happen with a decent growth rate, probably double digit for a very long time, because what we're doing is participate to the digital transformation of the world, and that transformation is going to happen for sure. We are one pillar of IoT, of communication. I think we can be identified as the green pillar, because whatever we do has an impact on optimization of the industrial process, taking care better of the environment, of reducing space in building, protecting the forest, take care of wildlife, improve the agriculture production with constrained resources, save on energy, save on water, etc. So that is a necessity, because we need to make the world needs more efficient resources. More efficient use of resources, and also some resources are too big to fail. Meaning that it's not about increasing the price and the system is going to adjust. If you increase the price of energy, you see failures in companies. If you increase the price of food, you see people starving. So we cannot afford that. We have to make the world more efficient. So we need to have this sensors, because sensors are the only way to improve one thing. You need to measure it, and that's what we do. For instance, our CO2 impact, when talking about energy, is much higher than the financial impact. When people deploy sensors in buildings to save on heating or ventilation or lighting, they have a return on investment. So they pay off the sensors with savings. However, the ROI, so there is a monetary return on investment. But the CO2 return on investment is even shorter, so it's even bigger, because we replace energy, which is the highest content in CO2 per euro spent, with basically sensors, intelligence, service, and work of labor of people, which has per euro a much lower content in CO2 because of this added value. So we are the green pillar. I think we are the green pillar of IoT. We're going to be identified like that for the decade to come. And also, we are a green technology. So I think we can be identified as a green pillar of IoT, but our technology itself is also green in the sense that we are low power. We can have energy autonomous end devices thanks to energy harvesting. And the dominant technology to do that is photovoltaic, so light or indoor light harvesting. We see more and more sensors, for instance, temperature, environmental sensors in buildings that do not need a battery. So that's good for the planet because no batteries. And it's also good for the ROI, for the total cost of ownership, because you don't need to replace the batteries, which is a burden. So again, there is a financial ROI and there is an environmental ROI. And we're doing both as the green pillar of IoT.
Mm-hmm.
So that's long term, what I believe our future is. But I also like to talk about one short term thing we're working on in the LoRa Alliance. It's I think it's a proof of maturity that we work on that. It's drive-by, so it's a new, well, not a new. It's new for LoRaWAN, but it's been there for many years now with other technologies. It's a new way to deploy a network, which is more opportunistic, either from a driving car or driving van, which collects sensor data as it goes on the tour, or even more opportunistic on, say, garbage collectors that drive every day in the city. And we're going to do that efficiently with a beacon that the mobile gateway is going to transmit, and the end device will have already a low power mode to detect the beacon. It's the same principle as in the relay operation. And upon reception of the beacon, the end devices will transmit the data they need to transmit. That's really low power from the end device side, and it's very low cost from the point of view of the network deployment, because you only need a single gateway, and possibly you don't need to add. Maybe you already need to drive in the city from time to time, so it's not adding anything to the operations of say the water meter operator. So that's a more short-term thing that we're doing with Actility, by the way, in the LoRa Alliance, and which is really it's really interesting to see that we are adding this option now. Mm-hmm. We are completing the toolbox.
Yeah, so it's an ever evolving toolbox. I mean, it's not surprising to see technologies adding new features, but what I'd like to underscore is how easily we do that. We have a really good foundation as the LoRaWAN architecture, and whenever we identify a need that is mature enough in the market that needs to be served, we're able to add these new features to the LoRaWAN, like the firmware update, like the relay, roaming, and walk-by, drive-by reading. And these are really nice modular additions, which I think validates what a solid foundation we have. And I also like to highlight the term that you have used. The first time I heard about it, the green pillar, because we've been talking about LoRaWAN becoming the fourth pillar of wireless communication technologies. In addition to cellular, Wi-Fi, and Bluetooth, the fourth pillar is becoming LoRaWAN. Now, you said it's a green pillar. That's a major distinction. I totally agree. It's fantastic. We should really color that pillar green and not just keep it as the fourth one on the side, but move it to the center, because that's what's going to hold up the roof to give a really good support as being the green one. I think that's just great. And then if our viewers are like already excited about what they heard from you today, and they want to be part of this revolution or building this revolution technology, we can tell them to join the LoRa Alliance if they are not already a member. And the moment they join the Alliance, they should come and join us in the technical committee. We build this technology in a very open, collaborative manner through meetings, face-to-face, and the Zoom calls and all that. And also with the larger ecosystem as the specifications become available to general public. And with that, I'd like to thank you, Olivier, for this super insightful conversation. Thank you for sharing all this, and thank you again for your fantastic contributions. And hopefully, we'll continue working together for many years to come. And then I would like to thank our viewers as well for watching us, and hopefully we'll meet again.
Well, thank you, Alper. Thank you, everyone, and I hope to see you in the LoRa Alliance or in other situations. Thanks again. Bye-bye.
IoT is an ecosystem play. Building a full end-to-end solution requires multiple partners to come together and bring solutions and services to the market. We'd like to introduce one of our valuable partners, M2M Germany. M2M Germany CEO Marius Nicolai will tell us how they take a technology like LoRaWAN and the associated connectivity platform like ThinkPark and bring to the market?
Yeah, thank you for having me in this new video series here with Actility. My name is Marius Nicolai. I'm the CEO of M2M Germany. We have been partnering with Actility for more than 4 years now. And in total, in our company, we started working with LoRaWAN in 2016 already. So yeah, I think we can say we have been more or less early adopter of the technology, which also means we've been doing a lot of marketing for the technology itself during the first years of LoRaWAN. And first of all, I like to say that it's great to see which role LoRaWAN nowadays plays for digitalization in various industries, different applications, and that is also what I'm going to talk about a bit later on. I'm going to present some of our projects we have done together with Actility. So, but first of all, actually, who am I? Who is M2M Germany? We are value-added distributor system integrator specialized in M2M IoT solutions, especially LoRaWAN technology, obviously, but also others. And our mission is to help our customers out of various industries and market segments to use wireless technology in their applications. So that is what we do. We deliver the hardware, but also the knowledge to our customers. As you can see here, we are a German company based close to Frankfurt, so right in the center of Germany. Small, medium-sized enterprise, basically, like 25 employees currently. And to increase our knowledge, we also partner with a couple of universities in various projects to gain knowledge in new technologies. So what exactly are we doing? So I'm trying to show that on this slide. Basically, all we do is industrial wireless data transmission. So everything we do is related to wireless technologies. First of all, of course, LoRaWAN, but we are also working with mobile radio like LTE, 4G, 5G, Narrowband IoT, Bluetooth, etc. So we are experts for the wireless data transmission. We, to be honest, we don't care too much about the application. So on one side, it can be some machinery, some PLC, any kind of sensor. We take the data, we transmit it wirelessly, and we bring it to some application to make use of the data, to visualize it, to bring efficiency into processes, basically. Doing that, what does that mean in terms of LoRaWAN? For LoRaWAN, we consider ourselves as a LoRaWAN full service provider, which means on the one hand, of course, we bring the hardware like the LoRaWAN sensors, gateways, even the modules for integration into existing hardware, for example. But it is way more than that, because you also have to set up the network according to the needs. So part of our offering is also the LoRa radio network planning, as well as workshops to train our customers and partners in usage of such kind of technology. And in the end, it's also all about physics, like the right antennas, the right placing for gateways, etc. So that is what we mean by LoRaWAN full service provider. And in the end, it also means the customer doesn't need the network itself. Is just the way of communication. So the data is needed in some platform, being it some ERP system or whatever. So of course, we also support our clients to integrate the data that they gain via the LoRaWAN network into their existing system, being it some ERP system or any kind of cloud platform, dashboard, energy management, whatever it is. So coming to the point why we decided to work together with Actility, actually it's a really strong partnership. Actility has been there since the very early beginning of LoRaWAN as one of the founders of the LoRaWAN Alliance. And in Actility, we found a really strong partner for for our projects that we do. So I think we can absolutely say Actility is the market technology leader in this in the LoRaWAN world. And yeah, for all the different projects that we do in different industrial verticals, also for utility companies, for smart cities, we have a really powerful platform that we can deploy as a software as a service, or even on-prem, which is good for some industries. It's a very scalable solution. We have I would say almost perfect network management capabilities. It's absolutely secure. So we're also working in automotive industry, for example. So the Actility platform gives us the perfect backbone for our projects. And on the next slides, I'm going to introduce some of the projects we have already done. So you can see a bit of the bandwidth of the different applications for LoRaWAN in total. First of all, I would like to share this use case that is about predictive maintenance in a brewery. So it's one of my favorite projects, actually. Not only is because of the beer, but it also has a really a good, clear value that this project is bringing. So the first, as the headline says, the first thing it's about is predictive maintenance. So we are monitoring pumps in the production process inside this brewery, and we already proved that we can avoid breaks in the production process, which are quite expensive if the whole production run has to stop because a pump is breaking down. And by using these kind of predictive maintenance sensors that are connected via LoRaWAN, that's a very good solution, bringing a direct, clear value for the customer. It's quite easy. It's an let's say add-on to their existing systems. Of course, they have a production management system, and on top now we have LoRaWAN inside the brewery. And the data goes into their production management system. Beside the monitoring of the pumps, there are some extra applications, like they also started to monitor temperature, humidity in some areas of their buildings in order to give this data to the building management. And this is also one fact that I would like to share. LoRaWAN, once the infrastructure is there, it is it's just a digital infrastructure. It can be used for any application, and the value of the network is even higher if you have several applications running on it. So, and this is the perfect example, because it started with the monitoring of the pumps, which is the clear use case, and then they said, hey, okay, there's some other applications that are interesting as well, and it's just about buying a couple of extra sensors, and there you go. Last but not least, a brewery is not an easy facility for a wireless network, but even so, with 3 gateways, we are able to cover the area of a single brewery. So here you also see that LoRaWAN has quite a good range also inside buildings, into complex buildings, with a lot of machinery and a lot of metal inside. The next use case I'd like to share is completely different. This time it's about the utility company. It's a local utility company not far from our office, actually, the Stadtwerke Gießen. And here we have more or less the opposite. It's not about a single industrial ground that we are covering. Here it's about a complete county that is covered by a network. So far, it's about roughly a bit more than 500 square kilometers that are covered with, I think it's 25, maybe a bit more, 27 gateways or something. And they use the LoRaWAN network for various applications, like obviously metering, especially for the water meters. But since this application started during COVID times, CO2 traffic light in schools were one of the first applications there. They have some indoor climate monitoring and some public buildings in the area. So that's the let's say a bit of the opposite of the first use case, to show you the bandwidth of the different solutions that are possible with LoRaWAN. Next one is one of our quite early projects, and I choose this one to share it here because it also shows very good the coverage that can be reached with LoRaWAN. So this area you can see here on the photo has about 200,000 square meters, and this area is actually covered by a single gateway. It's, to be honest, it's not the perfect approach. Usually you would use 2 or 3 gateways for redundancy. But here we can see how powerful in terms of range LoRaWAN can be. The use case here is that the different vehicles on the manufacturing grounds here have to be tracked, because they have up to 1,000 vehicles here that they are working on, and they need to find where exactly on their ground inside this 200,000 square meters the vehicles are placed right now, to bring it to the next production step. And this is solved with some LoRaWAN trackers working seamlessly indoor and outdoor. Indoor, the locationing is done by Bluetooth beacons. And last but not least, that's different. It's not so different from the case before. It's also about tracking. In that case of cable trams, so it was also a utility company that is doing this. And here we were using basically the inside of the Abbyway trackers, which is part of utility, and we did customized housing for that, to be able, as you can see here on the picture, to place it inside the cable trams. Here it's also about using the LoRaWAN network to find where these cable trams are located, and also do geofencing in order to prevent theft, because these huge cables are not cheap, and so they are regularly stolen. And to avoid this, these cable trams are now being tracked. That is what I wanted to share. And last but not least, again, thank you for being part of that video. And I hope I could show that LoRaWAN is a very flexible digital infrastructure that can be used in many different applications. And if you would like to know more, if you have something in mind you would like to discuss about, just reach out to me, reach out to my colleagues at Actility. And thanks for watching. Thanks to Alper and to Actility for that video.
Firmware updates over the air, especially over the unlicensed band, it is definitely not an easy feat. And that's exactly what we have cracked in the LoRa Alliance, as we have developed the interoperability specs for the so-called FOTA, firmware update over the air feature. And here in Actility, we have a very reliable, secure, and efficient implementation of the FOTA technology, FOTA feature, through ThinkPark FOTA. And I would like to introduce the FOTA server product manager, Eyal Bruto, who will be telling us more about how FOTA technology or the FOTA feature works and how we have implemented it with ThinkPark.
Hello everyone, my name is Eyal Breton and I work at Actility as the product manager for ThinkPark FOTA service. In this video, I will introduce FOTA. We will try to understand why it exists and how it works, generally speaking. Then we will dig into the Actility product called ThinkPark FOTA service. And at the end of this video, I will demonstrate a real FOTA campaign with 2 devices. So now let's see why FOTA exists for LoRaWAN devices. LoRaWAN devices may be installed in remote or hard-to-access locations, and they may be installed there for more than 10 years. In 10 years or so, as any IoT device, softwares improve, LoRaWAN standard evolves, and security breaches may be found. For all these reasons, there must be a way to update securely and remotely the firmware installed on LoRaWAN devices, either to update the user application, to add new features, to update the LoRaWAN stack, to support a newer version of the LoRaWAN standard, or to update any part of a device firmware. LoRaWAN uses local ISM bands and is known to use very low battery consumption. But to send big files, for example a full firmware file, which could take around 100 kilobytes, we need to consider a few things. One of them is the power consumption. We do not want to drain the battery of devices while receiving all the fragments of a big file. We also have the radio capacity. Because LoRaWAN uses ISM bands, local regulations need to be respected, especially for duty cycle. We have also device complexity, because usually LoRaWAN devices are limited in terms of resources for CPU and memory, so they tend to use simple algorithms and avoid, let's say, complex and greedy libraries. And then we have the multicast security, because if one device is compromised, we do not want to compromise the security of all the other devices in the fleet due to the multicast setup. So now let's talk a bit about the EU Cybersecurity Act. The goal of this act is to establish a cybersecurity certification framework. And to do so, the ENISA will play a key role. The ENISA stands for European Union Agency for Cybersecurity, and they already published guidelines in a document. And in this document, there is one particular requirement which says that it must be possible to push security updates to IoT devices. That's typically what FOTA does. And we also know that the EU Cybersecurity Act will enforce ENISA guidelines, making FOTA mandatory for IoT devices in Europe in the coming years. We see this trend is in progress in the US, and we believe it will spread across more countries very soon. So now let's see how FOTA works. So in this overview, we can see there are three parts. We have the device part on the left and the application server part on the right. In the middle, we have the LoRaWAN network server, which make the link between the application server and the device. When we talk about FOTA specification, it's actually a set of applications, because the FOTA specification includes multiple applications. We have the clock sync, the multicast control, the fragmentation, and the firmware management. And the role of the FOTA service is to generate a series of commands which will be sent by the application server to devices to prepare them to enter a multicast session. During this multicast session, the devices will receive the big file, so it will not be sent as is, it will be sliced into fragments. And at the end of the multicast session, the devices will be able to rebuild the initial file and to install it. That's basically how FOTA campaigns work. So far, I was speaking about FOTA specification, but I should have said FOTA specifications with an S, because FOTA is actually a set of multiple technical specifications. It's commonly said that there are two versions of FOTA, FOTA v1 and FOTA v2. FOTA v1 includes 3 technical specifications for 3 applications, and FOTA v2 brings 2 more technical specifications for 2 new applications. The first application is remote multicast setup. Its role is to assign a temporary multicast identity for devices, so they will have a multicast dev address and multicast session keys. And its role is also to define, to configure the multicast session. So when devices will have to enter this multicast session, if it's a class B or a class C, and which data rate and frequency to use. The fragment data block transport is an application used to define what will be sent inside the multicast session. So how many fragments, which size, and if redundancy fragments will be sent. The app layer time synchronization is used for devices to get their clock synchronized. So this application is for LoRaWAN devices 102 or before, because LoRaWAN devices 103 or upper, this reduces the MAC command device time rec. And then we have the last two applications, part of FOTA v2, the firmware management, which is used by application servers to request the running firmware version, but also the firmware version which has been downloaded by the devices. And there is also one command which is triggered by devices to report autonomously their versions to the application server. So the application server can build a map of the running firmware versions running in the field. The last application is the multi-package access. This one is optional, and its goal is to combine multiple commands into one command to make it quicker to configure and run a FOTA campaign. Because there are multiple applications, when the device receives this command, there is one F-port per application. So there are F-ports defined in the specification. These are default ports. They can be modified. But the default ports are 200 for multicast, 201 for fragmentation data block transport, 202 for the time synchronization, 203 for the firmware management, and 225 for the multi-package. Thanks to FOTA specifications, it's now possible to cover a large spectrum of multicast use cases. There are two big families of use cases. First, if we need to send large payload to a fleet of devices. And the second family is if we need to send a synchronized payload to a fleet of devices. So I just listed 4 use cases here. The first one is in case we need to upgrade the firmware of a fleet of devices. Obviously, FOTA specifications have been designed for this use case, but we could also use these applications to reconfigure a user application by sending a set of new parameters, for example. But also we could have the use case where we want to on demand switch on or switch off the lights in the streets of one city. And the last use case in this slide is in case of emergency procedure in one area where there could be earthquakes. There could be a procedure to shut down, to cut the distribution of water, gas, and electricity. So to prevent any more accidents in this area. And multicast is perfect for this use case because it will propagate the downlink to all devices in the area without overusing the radio network. So now let's discover ThinkPark FOTA service. And let's start with the call flow of a full firmware campaign. So on the left we have the FOTA server hosting the FOTA service, and on the right the end devices. In a FOTA campaign there are 3 big phases. The first one is the unicast phase, where multiple commands are sent. Then there is the multicast session, where the multicast fragments are sent. And the last one is using unicast to report the device version. In the first phase, in the series of commands, the first one is the multicast group setup request, which is used to install the same multicast identity on all the devices part of the campaign. The multicast entity, it is the dev address and the multicast session keys. The second command is the device reboot time rec. It's optional. It can be used to specify the date and time when the device will reboot at the end of the campaign to install the firmware. It can be useful for, let's say, devices, if some devices are used to send data during daytime, and if we don't want to impact the service by rebooting the devices during this daytime, we can specify a day and time at night to avoid impacting the service. The third command is a frag session setup rec, so to indicate to devices how many fragments will be sent, are expected, their size, and also if redundancy will be used in the multicast session. And the last command is the multicast class B or class C session request, so to indicate the rendezvous time, meaning the time when devices will need to enter the multicast session, but also which data rate and which frequency will be used to send fragments. So once this first phase is done and the rendezvous time happens, all devices enter the multicast session, and the FOTA service starts sending fragments. There are two types of fragments. That's what we call the systematic fragments. In the spec, they are called uncoded fragments. And there are also redundancy fragments. In the specification, they are called coded fragments. The coded fragments are part of the FEC algorithm, the forward error correction. Let's take an example. If a device misses fragment number 2, without redundancy, the FOTA server will have to send again fragment number 2, and this fragment will have to be received by the device to be able to rebuild the target file. Whereas when redundancy is used, I mean FEC is enabled, with any coded fragment, the device will be able to recover the missing uncoded fragment. So it's much more efficient. That's why it's highly recommended to use FEC in campaigns. So now that all the fragments are sent to devices, devices will reassemble all the fragments to rebuild the target file. The signature will be checked and the firmware will be installed on the device. After the reboot, to install the firmware, the device will report and will enter the third phase, which is sending the unicast uplink with the command device register rec, in which the device reports its firmware version. And with that information, the FOTA service will know if the device has been upgraded successfully, if it's running the target version of the campaign, and also if this message is sent outside of a FOTA campaign, it will allow to build some kind of map of all the firmware versions running in the field. So it's very useful to maintain accurate information about the versions running in the field. The goal of FOTA campaigns is usually to upgrade the firmware of devices. To do so, we discussed only one option so far, which is to send a full firmware file. Such file can take up to 100 or 200 kilobytes, and depending on the ISM band and the spreading factor, it may take a huge number of fragments to be sent in the multicast session. So to limit this number of fragments to be sent, Activity developed a unique feature called the Smart Delta. The principle is pretty easy. Instead of sending a full firmware file, we send a patch. And this patch is generated on the FOTA server itself by taking the source firmware and the target firmware by creating a patch file. This patch is compressed and signed. So with this, the patch is very small and the reduction factor is about 10 compared to a full firmware file. Meaning instead of sending a full firmware file of 100 kilobytes, we can send a patch file of only 10 kilobytes. On the device side, to be able to process this patch, Activity provides a Smart Delta library which contains the key to be able to check the patch signature and also the algorithm and the logic to install or apply the patch on the device by taking the running firmware of the device, applying the patch to reconstruct the target firmware and reboot to install this new firmware. To illustrate the benefit of Smart Delta feature, we took one real-life example with a production ABIWO device. So we have here the consecutive firmware versions of ABIWO device going from version 1.40 to 1.74, and we have the size of all the firmwares going from 84 kilobytes up to 96 kilobytes. And we generated patches between each version n to version n+1. And we built this table here, and in average, the firmware size is 90 kilobytes and the Smart Delta size is 8 kilobytes, meaning the reduction factor is about 11 to go from one version n to the version n+1. If we take the worst case scenario, going from version 1.40, so the oldest one, to version 1.74, the newest one, instead of sending a 96 kilobyte full firmware file, with the Smart Delta feature, we would have to send a patch of 25 kilobytes, which is a huge saving. As you will see in the demo, ThinkPark Photo Service works, and it works well. That's why we have several customers already using it. For example, we have Swisscom with devices in the cold chain monitoring. We have 2 customers in the water metering business, Arad and Rubicon Water, and we have TWTG, a customer in the industrial IoT. And now it's demo time. We can see now the login page of the ThinkPark Photo Service. Once I'm logged in, I have access to all the items of the service. I can view things and also update many of them. So we can check user information and update the password. We have access to subscriber configuration, where we can check the maximum number of devices and the maximum number of multicast groups which can be created in this account. We also have the license to unlock the Smart Delta feature and the possibility to use Smart Delta patches. We have the device profiles here. They could be called hardware profiles because they mainly contain hardware information, because we have to specify the producer ID, module ID, hardware revision, and hardware version. And basically, the device profiles are attached to files and to devices. They are the link between these 2 types of items. And when running a campaign, when starting a campaign, if we try to push a file on a device which is not attached to the correct device profile, the device will be automatically ignored in the campaign. This is to prevent sending the wrong file to the wrong device. We have Smart Delta keys. So these keys are used by the server to sign the patches, the Smart Delta patches. And this key, the public part of this key, is embedded in the Smart Delta library in the device. So the device is able to check the signature and to ensure the patch is legit. If the patch is legit, it is installed and the device is processing the patch. Then we have the files. In this campaign, we will use this file to update the device. So we can see we have 2 types of files. We have the full firmware files. So they just have a firmware version. So we have the one with the version 1.3.0. This is the current version of my devices. And the one with the version 1.3.1. If we define a Delta firmware, we have a base version. So to update from this version 1.3.0 and to upgrade to this version 1.3.1. We will use a Delta patch in the campaign. Then we have the regions, which are a set of multicast groups. And the multicast group is the multicast identity, which will be pushed to devices using the multicast group setup. So we have the dev address, the frequency, the data rate, and the redundancy. We also have the multicast key. It's similar to the APP key for OTA devices, and the multicast session keys will be derived from this multicast key. This key can be random, it's okay. Then we have device sets, which are a list of devices, and devices are defined here with a dev UI, a name, if they are capable of doing class B or class C multicast sessions, if they are LoRaWAN 1.0 or 1.1, and which version they are running, but also which version of FOTA they are compatible with. In my case, I'm going to use these 2 devices, which are compatible with FOTA version 2. And the last item is campaigns. So we can have a summary of all the past campaigns, if they were successful with a tick, if they were failed, but also they could be stopped or configured. We will see the configured state just after. So when my setup is complete, I can create a campaign. I have the choice between creating a campaign by copying an existing one or by creating a campaign from scratch. So let's create one campaign from scratch. I select the campaign type. It can be FOTA campaign, so to push a firmware file. It can be upload binary file. It's the same type of campaign than FOTA campaign, except there is one less step, which is the last one. Once the file is uploaded, we do not check the version of the firmware running on the device. And then we have the configure multicast groups campaign. The goal is to push a multicast identity on devices and to configure a multicast session. So devices will be configured and ready to receive multicast downlinks, and one third application server will have the possibility to send multicast downlinks to a set of devices. So for this demo, we will do a FOTA campaign using FOTA v2. We give it a name. I select the device set with my 2 test devices. I select the region with my multicast group for the test. I select the file of I want to push to devices. So if I select the wrong file, for example, this one, a delta patch between 112 and the wrong FOTA version, I can see there is no device in the campaign. But if I select a valid one, so the delta patch to go from 130 to 131, there are 2 devices in the campaign. We have to set up a set of parameters here. So by default, the multicast session will last as short as possible. But if we want to extend this multicast session, we can do it. We can define the device reboot date and time, as we saw earlier. We can define also a reboot time spread. It's useful when we want to upgrade a large fleet of devices to avoid all the devices to reboot at the same time and having a surge of join requests on the network server. We can also define the fragmentation start date and time. This is used to define when the multicast session will start. By default, the multicast session will start as soon as possible, but we may want to start it at night or at noon, whatever, and we can define it here. We can define the delay between multicast fragments and the success threshold. So for this demo, I will put a low threshold to be sure it will be successful. I have a summary I can review and click on done. So now I can start the campaign right away, or I can go back to the list and see my campaign configured. If I want now, I can view the campaign, edit the campaign and modify any parameter. And when it's done, I have the choice again, either to go back to list or to start the campaign. When the devices are ready, we can start the campaign. So I'm gonna restart the devices. So you see the running version 130 for this one and 130 for this one. So they're running this version, and at the end of the campaign, I expect them to run the version 131. So I'm waiting for the devices to join, and once they are joined, I can start the campaign. So now when the campaign is running, the button changes here for a blue arrow, and I can follow the progress of the campaign here. So we can see the first device received the multicast group setup. The second one, not yet. So we have the second one received it, and we have the progress bar here for each stage of the campaign. So now we see it's a fragmentation session setup, and for each stage of the campaign, we will have a progress bar depending on the response of the devices. So here, one device responded to fragmentation session setup, and we are waiting for the second one to answer, and then it switches to the multicast class C session setup. The first one responded, we can see it here, and the second one as well. And now we are waiting for the beginning of the multicast session, where all the fragments will be sent. So now the data fragmentation session is about to start. The multicast session is about to start. We will see in the screen below the devices switch to class C, and the stage will start, and fragments are being sent. So we see that we expect to receive 5 fragments. 3 are sent, 0 are missed, are lost, and when all the fragments will be sent, it will check the patch, switch to class A, and reboot. And when the reboot happens, it will build a new firmware in a specific slot in the device. Then it will swap the slots, to swap the slot with the new firmware to become the slot of the running firmware. And now we can see it's running 1.3.1, version 1.3.1. So the last stage, it's to wait for devices to report their firmware version. And we can see this progress. We can see this in the progress bar here. So now I'm waiting for the devices to report their versions. So one reported the version, its successful, and the second one did the same. So the campaign now is stopped and is completed because the 2 devices reported the expected firmware version. And if I go back to device list, I can see that the device firmware version has been automatically updated to 1.3.1. So the campaign is successful. It's over. I hope you enjoyed it. Thank you.
Thank you for watching. We hope you have enjoyed the second episode. Don't forget to check out the description below the video, where we have shared more information and more pointers for your further reading and watching. And see you at the next episode.